Thank you, Andrew. Our next speaker is Sergio Moreno Rojas of G Growers, and he's going to talk a bit about salad and vegetable crop monitoring using remote sensing. Thank you.
Right, thank you. First thing I would like to say, it's a pleasure to be here in the Royal Society for the first time as a speaker. My name is Sergio Moreno Rojas. I come from Spain, as you can see from the accent. I work as a remote sensing technologist at G Growers. For those ones who don't know, G Growers basically is one of the Europe's leading fresh produce in right now, based in Cambridgeshire. We farm across not just in UK, where we are based, as well abroad in other countries such as Czech Republic, Poland, Senegal. But our main area is the southeast of Spain. What I'm in charge at G Growers is to run a remote sensing project, which we have called AgriEye, and we set it up 2 years ago in collaboration with Cranfield University. So that we got a academic partner to get the expertise, because as you can imagine, based on all this geographical spread of our business, we got different interest on Earth observation technology and what that information can offer to us. So that was the reason why we started looking at this new trend of drones, what they actually could offer to us, what were the limitations on how to operate them, should we integrate them into our internally and into our business, should we do it externally. So we contacted different suppliers, like at that time, Ursula Agriculture or others, looking at, arranging demonstrations in our fields. So gathering all that experience, and then, we made a decision saying, okay, should we invest on this? So we decided to take a different route instead. So in 2015, and the growing season that is currently ongoing, we wanted to make use of a very light aircraft instead. So it's a manned aircraft. It's the very light, it's the lightest category that you can commercially fly nowadays, because we consider it could be more cost effective compared to drones when you are up to scale the whole system up. So the idea was to demonstrate that we could actually do the same, provide the same service to all of our growers across the business, and provide the same products and outputs as drones were doing. And the second leg of the project over there was to undertake a commercial study using satellite imagery as well. So this light aircraft, which you can see here on the bottom right, is could be two men, but it's one man piloted. And it allows us to cover, you have here a map of some of our land bank. So we managed to prove our commitment of covering all our area, covering more than 4,000 hectares in a very cost-effective way, being able to have that flexibility in the payload to change the sensors and that we need from an end-user perspective, which is us. So you can imagine that the first product we were looking at and the most robust is the famous vegetation index maps. So the first thing was to prove and that this system was working fine, because this company was just starting to build up and learning how to fly and actually to do the aerial photogrammetry. So first thing to do was to go with our agronomists to see what was actually matching, trying to prove the value of this and to show what these colorful maps can provide in terms of information to them. So they can go and walk in a daily basis with the grower to the field and assess, all the, using this as a scouting tool straight away to address different issues on the fields. One of our main products are iceberg lettuces in terms of volume. So, well, all these growers are, when you go and see them to their sites, they are quite skeptical about what are these colorful maps. So you have to prove them and translate, all these colorful values into fresh weights, pounds, and you have to measure, and then you can manage things in general, right? So basically setting up trials over, in this case, specific features on the ground, what we call locally rodents, which are all river streams that they have a poor fertility. So that's how we actually were showing the growers what we could actually do with this, but not just using the very light aircraft. There are other sort of data sets that we were looking at as well. The Environmental Agency suddenly decided to release open LiDAR data. So these rodents, because the erosion on these areas work in a specific way, the rodents are a bit higher on the ground in terms of height. So you can extract these poor fertility areas using free open data from LiDAR and maybe use, target those areas to add organic amends, for example, and try to rise the fertility of those areas and get a more even crop. So we can provide our customers like, Tesco or M&S a better product and actually be, basically raise the yield in those fields. So the growers say, okay, we're going to use these maps. Should we start using precision farming in the way we usually do? Just maybe try and go and it makes some effect, but we actually have to measure it. So my team and myself, we go with the GPS and we try to set up those trial plots and to provide those measurements so we can scientifically and with numbers show the improvements, and then they will engage more with all this technology, because that's the idea, to consume all this information and Earth observations data and make most of it. So apart from the vegetation maps that are very good, some of the farmers, surprisingly, they were not interested in those. For example, some of them got very rich land with a very high content in organic matter. So there was a bit misleading in terms of the readings of the vegetation maps because of the weed pressure, but they were interested in plant counting. So knowing how much product available is on the ground. So in collaboration with Cranfield University, again, we have developed internally a plant count application and for sizing as well for every transplanted crop for now. So there is an example of an aerial imagery at 1,000 feet from our platform, and then they translated the process data looking at a snapshot of, in this case, lettuce, but we have proved it to be working on celery and in potatoes as well. So not just counting the population on, how much product is available once it's established compared to how much product was coming from the nursery, which gives a higher accuracy in terms of the figures. It's difficult to know, to be honest, how much is planted when you got huge amount of, a big amount of volume. So then the sizing comes up over here in terms of how the ground area covered by the crop, and looking at assessing the greenness of that area. So within just the same batch, which is supposed to be an homogeneous crop over there, same planting date, same conditions, the establishment is different. So you can expect different frame sizes to get different frame sizes at harvest, because different customers, they request different specifications for the product. So Tesco wants, bigger lettuces, or wants a bit smaller. So building a model to predict those frame sizes at the end, so that means quality product, not just amount of product, is a very valuable information for the business, for example. And even just with the NDVI maps, harvesting teams, they are using it straight away, saying, okay, we can expect different quality in this product quality in different areas, trying to allocate specific products for those areas, so trying to maximize the yield as well. celery hearts for this poor area, longer sticks for celery in the better area, etc. Deploying the labor in a different way, saving money and time. And the second leg of the project I wanted to show is our interest in looking, in this case, in Spain, where you don't have that much cloud cover for optical imagery. Of course, you combine it with radar in the UK, that could be an option, or even here. Was looking at, what can we actually do the same thing using, as we were doing with the aircraft, but in a larger scale in Spain. So yeah, we established a second leg of the project, looking at from October 2015 to May this year, if we can actually monitor our crops over there. So this is our land bank in Murcia, in the southeast of Spain, looking at if we were able to identify crops, the growth stages, and our cropping area as well. What we can actually do and monitor. Can we see if the drip irrigation is, as well in some of the fields, is not working well? So all those sort of questions, just having a look, and through Airbus Defence and Space as the supplier, and and that's mainly the whole work that we have been doing right now. So we are, as a business, we got the will and resources for consuming all this data and information, and we are quite hungry to see if we can start building more and more applications. That has to be always end user driven. That's why myself and my team are building, I think, that bridge between companies like Verkord or others and the final end user, which are the growers. So thank you very much, and open to questions.
Thank you. And our final speaker today is David Gardner for Innovation for Agriculture. And David's going to talk about opportunities and future potential for satellite and sensor technologies in the livestock area.